Hello? Hello? Can you guys hear me?
Yeah, can you hear me?
Cool. Yeah.
All right.
Let's wait for several minutes so that folks can join. Folks are trying to join this meeting. Can you guys like mute yourself if you're not talking? Thanks. All right, let's wait for one more minute and then we can get started. Thanks, guys. All right, I think let's get started. This is the Mesos Containerization Working Group. I think today's topic is going to be volume ownership and access control discussion. I think like I remember we had a discussion like several weeks ago on that, and we have a follow-up meeting between Twitter guys and Apple guys after that, and then we come up with some solution. But I still want to in this meeting I also put in like some Microsoft guys because we want to support Windows as well. So yeah, so let me jump into the doc. Wait a second. So we have this doc. I think last time what we did is we tried to capture all the use cases first, and then trying to see if there's any option that we can use to solve all these use cases. I think we came up with a bunch of user stories. So the gist of that, just to catch some folks up, if they're not familiar with this issue, is like so right now in Mesos, the volume ownership and access control is right now it's basically by the owner of by setting the owner of the volume to be, because Mesos support this. I think there's a design constraint. So we do have the concept of user in Mesos. So if you look at the put above definition of Mesos APIs, so there's a user inside frame info, so framework can set a user, and also there's a user field inside command info where like when you launch a command, you can specify the user that you want to launch the command. And that user maps to Unix account on the agent at the moment. So that's kind of design constraint because we need to maintain backwards compatibility. So we have to maintain that semantics to make sure we don't break for other people's current settings. So we have some design constraint, but I think the problem we have to solve is like, I think initially when we designed this, have this user, we don't consider like containers, for example. But right now with containers, and container itself can set users inside its own image. So that means like that means the ownership will be complicated because the user inside the container might not be the same user on the host. So you might have some access control, but you do want to make sure that the container itself should be able to write to its sandbox at the very least. So that's the first user story we captured. And also I think we have a constraint that like sandbox for each container must be protected, because if you have two users launching container on the same host, under different users, you do want to make sure that one user cannot see other user sandbox. So that's for security concern. I think that's a backwards compatibility requirement that we have to maintain. And I think we have some other like the user stories, like we have different kind of volumes. I don't know who added this table, but it kind of nicely capture all the kind of the volumes we have so far. Like we have like sandbox volume where so the sandbox itself, and also there are like volumes that you can like make a directory into the sandbox and then treat that as a volume and can bind out into the container. And we do have secret volumes, which is a ramfs that contains secrets, and we have persistent volumes, local persistent volumes. We have image volume, and we also have host volume. So image volume is like can specify an image, and then Mesos is going to prepare the image root for you, and then on the count and then bind mount that the entire file system root into your container as a volume. And we have host volume too. So we have all these kind of volumes, and we want to support. Is there anyone on the line that made this table? James, is that you?
Yeah, that was me. I made that table.
Okay. Can you explain like a little bit what that is? Like what does that mean by location?
It means where the volume comes from.
Oh, I see.
So it means where is the physical storage.
Okay.
So it's just trying to capture like, is this on the same host? Is it on a separate host?
Okay.
I'm not sure whether it was useful. It seemed useful at the time, I guess.
Okay. Well, what about access? What's access? What does access mean?
That's trying to capture the concurrency requirements. So is it single user access? Is it multiple user access? Do I have multiple concurrent jobs trying to access this thing? So the sandbox, you have a single task group accessing it. But a host volume, you could have multiple tasks groups accessing it simultaneously.
Mm-hmm. Okay, I see. Got it.
So typically, I mean, the main consideration there is when you have multiple task groups access simultaneously, you have to make a decision about whether all those task groups are working as the same user or not.
Okay, so basically you're saying like it's likely, if I understand correctly, you're saying like it's likely that the user for each task is different, and you want to make sure that all of them can access to the volume that's inside the
Yeah, I think we just need to define what those semantics are. I mean, they can be whatever we want, right? I'm assuming that every task within a task group is required to have the same user. That's correct, right?
Well, that's actually, this is not we don't have that requirement in the API. So essentially, like it's likely that like two tasks in the same task group can be under different user.
I guess I'm not convinced that's a good idea.
Well, I mean,
maybe we should have that. Maybe we should have enforce that constraint somehow.
Well, that's a separate. I think that's a separate discussion. I think like whether we want to allow that or not. I think that's a separate discussion. Maybe, for example, I can think of some cases where like you have a task group. Some of the tasks is privileged. You want that user to be under some special user, and some tasks that you want to perform is like underprivileged task that you want to run the task under like nobody. I can see use case for that.
But then in the storage, you have to figure out how to support that in the permissions model, right?
So that's I think that's
not
figure
straightforward at all.
Yeah, I think that's something we need to figure out. I think this is no different than like you have a persistent volume that's shared by two tasks on the same host and want both access to the same volume. I think it's the same issue that we need to solve.
Yeah. So probably in this doc, then we should make it clear that we do want to support that case, that we do want to support the case of task groups running with different users within the same sharing the same sandbox on sandbox path.
So in this table, perhaps it would be helpful to make a note that about where the user comes from, because in that scenario, I'm guessing the mechanism for having different users under the same group must be probably be using the users in the image, because otherwise the user is in the executor's command input, right?
Yeah, I think another thing here is like for task group, like the executor is the top level container is the executor container that has a user too. So that can be like, for example, root or nobody or any other user that launched the executor. So if we create a sandbox in the executor, so that's that. Yeah, I mean, I think that right now the semantics is that if you create a sandbox in the executor, it's contained. Like if you have a sandbox volume in the executor's container, then the ownership of that volume should be the same as the executor's user. And then if you have tasks or task groups under that executor that wants to access to that sandbox path, it's up to the permission. So the access control is governed by the user of the task and the user of the sandbox path volume. So that's the current semantics. I don't know so it's likely that, for example, if you have a executor container has a sandbox path called like foo, and then there's a task group which is a nested container trying to reference to that volume, and that container is under nobody, and there's nobody cannot access to the executor containers sandbox paths based on the access control Unix permission, then there will be no access to that volume. I think I think we should definitely like clearly define what's the semantics should be, like what's the access model we gonna what's the semantic we want to provide. I don't think we captured that. That's a good thing. By the way, so can someone volunteer to take notes in the working group meeting notes?
Yes, I can do it.
Yeah, so, thanks Gilbert.
So I need to clear some background on here because it might be confusing for some people. So right now, we have the user in framework info. So it is the basic user. And if it is set, so it will be the user. Otherwise, it will be the user who launched the framework process. And this user gonna be passed into no matter the executor or the task. So but they can be they can be overwritten. For example, you can define command info in the executor info, and also you can define command info in the task info. So which means like you can set a user for comments, and then if you override the default user either in your executor or task, which means so if you are building your own custom executor, and your custom executor can specify with a command, and that command can come with a user which overwrite your framework info user. So those are the complicated part here because we have semantics which I regard it as a tech debt. So maybe we want to adjust the user semantics from the task, from the command into the container info to bind the user semantic with the container.
Yeah, I think Gilbert, let's not try to dive into too much detail here. I think like let's keep the discussion at a high level, like what kind of semantics we want to provide. I think like we definitely need to solve the sandbox volume case where like I think the semantics we need to discuss, like what the right semantics is, given that each task can have a user and the top level container can have a user, and then what the semantics we want to provide. We can, so that's the to-do things that we need to do, but I think we only have like 45 minutes. Let's keep moving. So I want to get out of this meeting as much as possible. So sandbox, I think we already discussed that. We want to make sure that a container has each container has a predefined sandbox, and we want to make sure that container at least can access to that sandbox by reading or writing, or at least creating files in that sandbox. The owner does not necessarily need to match. Like right now, the way we allow container to be able to access to a sandbox is trying to change owner of that sandbox to be the same user as that container. But this might not be the semantics we want. I think the goal is trying to, I think we mentioned in the user story, the goal is just trying to allow users to be able to create new file directly in that sandbox and be able to write and read the file that it creates. I think that's what we want to provide. Any comments on that?
So two containers with the same user that means access each other's sandbox?
No, that's not true.
So how would we support, I mean, probably I'm not, I don't understand the semantics completely. Like if we are pegging the ACLs based on the user that's associated with the container, how do we stop one container from accessing some other container sandbox if the ACLs are pegged against the user?
Yeah, so right now, if two containers are on the same user, then nothing prevents from these two containers to be able to access to different containers sandbox. But if you do want like isolation, you want to make sure that these two containers are in the different users when you launch the task.
Okay, and so who authenticates the user?
So there's an APL in Mesos. When you launch a framework, you need to get authorized to be able to run.
So the authorizer module does it.
Yeah. So there's an authorizer in ACL, especially for like which framework can launch under which.
Got it. Yeah. So okay. So that's it.
So you can set up those ACL to make sure that
makes sense.
Okay, so we have secret volume, as I mentioned, it's a ramifest. I think like this is like a per container. I think all these are per container except for this one, which is kind of tricky, which is the sandbox volume. All right, so I think that's something we captured last time. I hope that you guys read the notes. But I think we came up with some solutions. I do want to get some feedback from Microsoft guys on that. I think, so one solution we came up was to use supplementary groups. That's the same route that Kubernetes took to solve their access control issues for volumes. So basically what they did is for each pod, you can specify a FS group in their spec in the API, and the FS group is just an ID, a number that maps to a group ID on the host. And so when a pod uses a volume, and the Kubernetes will try to like recursively change the group of that volume to have that to make sure that like the owner of those volumes, like all the directories, the owner of the owner. So basically, do a recursive change owner, change group to match that FS group. And then also when they launch the container in that pod, make sure that the container's supplementary group has that FS group. So that it makes sure that that makes sure the container process can access to the volume. And also another thing they did is they do a set GID on all the directories, not just one directory. They do a set GID on all the directories in that volumes, so that that makes sure that whenever the directory that or files that that container creates is going to be under that group, to make sure that if two containers in the pod share the same volume, they can access to each other's file. So that's how they did.
At what point did they do the recursive set GID? When you attach?
When they mount the volume in the pod.
Okay, so you do it once at startup.
Yes.
So as the task uses the volume, you're going to have.
Yeah. So each pod has
not set UID, and then when you detach it again, that'll be made consistent.
Yeah. So every time you mount a volume, they do this recursively change group thing. And if that volume is used by a different pod, then and that pod has a different FS group, then they recursively change the group again.
Sorry, I think that's not true. They're setting GID and ownership when they create a new volume. That's
not mount.
Yeah, when they create a new volume and your directory, it will be empty. So they set ownership and set GID flag on that directory, and then they just use it. That FS group is a proper volume, not of a container.
So it only does that when the volume is being created, not the.
Yeah, I think so.
But the creation of the volume can be like, for example, remote, right? I don't understand that part. Like, for example, I create a EBS volume. That can be remote. I mean, you cannot change the ownership until you mount the volume. So that's something I don't understand. Maybe we should dig that deeper, see what they did.
Yeah, I agree. I mean, unless you mount it, I don't know how you would set the set GID, because set GID is a local operation, right? On the mount point.
Yeah, my understanding is they do that every time they mount, because that volume can be used by different pods under different FS group later. I don't know, if they don't do this, how they make sure that the pod can access to that volume. So maybe that's something we can check. Gilbert, can you take a note on this one? I can double check on this one. Anyway, so I think that's how they solve the issues, because they want to. I think their user story is like all the containers in the pod may be under different users, but they do want to make sure that all the container can access to the persistent volume for that pod, which is kind of similar to some of the cases that we want to support. So that's the reason we came up with this possible solution called supplementary group. That I think can kind of solve these issues. But I think the solution is very Unix specific. Another thing I don't like is like every time you the other thing I don't like is every time you have to do a recursive change owner thing on the volume, because you have to. So set GID only applies to the direct descendant of a directory. So if you want to make sure that all the files created inside that volume are under that given group, you have to recursively change the group ID to call set GID on all the directories, which is unfortunate.
So the set GID semantics are different between BSD and Linux as well.
Oh, I see. So what's the semantic in BSD?
At least in Linux, I think Ilya checked on the GNU website. So Ilya had a note on the doc that set GID is inherited on Linux, but I checked it on Mac and Linux, and it's inherited on Linux, but not on Mac. So
I see.
I think inheriting the set GID bit is a Linuxism.
I see. So inheritance is like the setgid inheritance, because I do some simple experiment on my Mac. It's not inherited, but I haven't tested on Linux. So
Right, try it on Linux.
okay, I
So
see.
I did some experiment on Linux. So if you do a by mount, no matter it is the dash r by or just the dash n by mount. So if you always inherit from the source to the target, which means after the mount, so both source and target it will be under the same user and permission from the original source user.
Yeah, but why? Okay. Anyway, I don't think that's relevant to the discussion.
Okay,
yeah.
sorry.
Yeah. Okay. So that's one idea. So supplementary group. I think. Okay. There's some like that's a good idea. So Gabriel, can you take the notes like set gid?
So I was just curious, what was the lifetime of that supplementary group supposed to be? Is it expected to already exist on the system? Is it created when it's requested and then deleted? I don't know.
So that's up to our design, basically. Like one solution for that is like agent can reserve a bunch of IDs, say, hey, no one can use those IDs. And then every time there's a container launch, we automatically assign like a supplementary group ID to that container. So that's one solution. Or we go with the Kubernetes model where you ask the user to specify the ID, which I don't like, because like how the hell the user can know an ID on a given host, and that ID might be different on different hosts. So yeah, I don't like that thing.
Yeah, and I really don't like the idea of the ID when we go over to Windows, where a group and ID don't really map. We might have a group name, but we don't have a group ID for sure.
Okay. Yeah. So I don't like the idea for sure. So okay. So I think that's one. So Gilbert, did you document the setgid semantics is not different? It's different on BSD and yeah. Let's. Okay, so supplementary group is one solution that we discussed. Another solution I think we discussed, but I don't think we dig deeper, is the ACLs. Like there are different kind of ACLs. So I did some digging on like a POSIX ACL. So James, you mentioned that I saw your comments on the doc. Like you mentioned that rich ACL. Like what's the ACL used by NFS?
Rich ACLs are basically the NFS v4 ACL model, which is basically the Windows ACL model.
Okay.
So you have names in there instead of IDs and that kind of thing. So I haven't studied in detail the specific differences between rich ACLs and the traditional Linux POSIX ACLs, but I did look at their patch history. It doesn't seem the rich ACL patch has been around for a long time, and it doesn't seem like they're immediately going to be upstream all of a sudden. So,
yeah, and also I think the rich ACL, I look at the way how Linux can use that rich ACL. It's kind of tedious. You have to remount the root pretty much to support that, based on the documentation I saw. Like you have to do a remount to enable rich ACL. And I look at the existing, like not the rich ACL, the POSIX 1E ACL on Linux. I think the one thing that's missing is the inheritance. That like you probably still have to do a recursive the default ACL for each directory. You have to do that because I think it's not inherited. I'm not sure like whether like Windows ACL or NFS ACL solve that issue, but you can have an inheritance. You can only set some default ACL in the top level directory, and that will get inherited by all the files, all the subdirectories in that volume.
Yeah, Windows ACL model has proper inheritance that works kind of the way people think of it. So what you do in Windows, and this is the same, I believe, semantics that a rich ACL gives you, is at the root of a directory hierarchy, you apply what's called a protected ACL. And that's basically an ACL with a bunch of flags that says inherit from me, but don't inherit onto me. And then the shell API takes care of propagating that every time you create a file system object underneath it.
So that's like, even if you have like a very deep directory structure, it's inherited from the top level.
Yeah, exactly.
Okay, so yeah, that's something that I really want. If we can have that, given compared to well, I think on Linux is fine because setgid it's inherited according to the experiment you did, but it's not consistent on BSD. But I think like right now I feel like it's gonna be very hard to find a solution that works on all the platforms. I also remember one discussion I was part of the discuss. I heard one discussion that people have during some of the Kubernetes 6 storage, saying that like supplementary group is the only way of solving that problem that works for I don't remember what the platform he mentioned, but he mentioned that it's the only way on Linux, I think. Without, I mean, rich ACL is probably like not merged or like it's hard to use. And also I think the ACL, another downside for that is maybe, I'm not sure if all the file systems support that.
Yeah, every ACLs are just based on extended attributes. So everything that supports extended attributes has ACLs.
They have to support extended attribute because they store those ACL in extended attributes.
Yeah, but that's everything that is in practical use, I think.
Okay.
I think that the big drawback about trying to go an ACL model is that they're used so rarely in the Linux world that I think people aren't really familiar with the semantics, and I think they're going to cause a lot of heartache among operators because it's something that almost no one uses.
Okay, I see. Okay, so maybe we should go down the supplementary group path a little more and see what's missing and what we can do better. I think I don't realize that on Linux setgid is inherited. That's good. So at least on Linux, this is a pretty good thing. I think probably don't care about BSD at the moment. I'm not sure. I'm not sure. Like Microsoft, the guys, do you have any experience on like on this kind of supplementary group support on Windows?
So I actually invite Windows Docker Container PM Patrick, but I think I don't see him on the list at this time. So this is Lee from Microsoft. So I think I work with Mesos field dev team, engineer team to support Mesos on Windows and then DCOS on Windows. So I do invite Windows Docker Container PM to the meeting, but I don't see him in the meeting list. So before the meeting, I actually do a brief sync up with him. So far, the implementation for the volume permissions port on Windows Docker Container is very limited. Pretty much they don't have any, anyone can read anyone's container. So they don't have any, limitation or privilege on the volume at all. So the one that you discussed about this ACS implementation, they don't use that for the Windows Docker container yet. So one of the goal for this meeting, actually, I would like to see, based on our implementation, we may have to go back and ask them to implement, some of the features for us. But while I go with the discussion by listening you guys, I realized that the Kubernetes pod actually also implemented a similar mechanism already. I know that another team in Microsoft also working on Kubernetes on Windows port. So my one of my thing I can do is as a follow-up, I can go back to them and discuss with them, how to support the port shared volume for Kubernetes on Windows. And then I think that those knowledge can help us to make a better design later with Mesos shared volumes.
Yeah, I think that's a good idea. Thanks, Lee. I think it would be great to get some feedback from those guys that does the Windows support for Kubernetes. Especially like Kubernetes already have this supplementary group. I'm curious how they map this to Windows.
Yes, yes. I think this is the I think start point for me, because I'm also curious if a Windows Docker container doesn't support this functionality, then how they implement it in the Kubernetes for Windows. So I'll follow up and then I'll come back to this group and update my findings. Okay.
Okay, sounds good. Thank you very much.
No problem.
I think like we have 25 minutes left. I would like to go through this option because I think that sounds like this is the most promising option at the moment. Other options like ACL, either it's not cross-platform or it's hard to use. Although we still need to use them
I
more.
wanted to point out on the ACLs, I think we should explore them because while I agree they're not frequently used, they're not entirely unused. I mean, you'll find the ACL package installed on most systems because like systemd takes a dependency on it. It is used on Linux to solve this kind of problem, at least every so often. It might still be a reasonable solution for us, although it's not widely used.
Yeah, I think the tricky part is on Linux. The default ACL, like the POSIX1E ACL, is not that useful, especially the inheritance is not implemented. You have to do a recursive change the default ACL for each direction in the data volume, which is unfortunate. Yeah, but I agree. Like we should dig deeper to do more experiments and see what's going on. And it's also like I want to wait for the feedback from the Microsoft Kubernetes port guys and see if there's any thoughts they have. It would be nice to have those.
Yeah, since we just joined this discussion from Microsoft, I would say at least wait for the second round while we get more info before we make a real design decision based on those feedback.
Okay, so Lily, when do you think you can get those feedbacks?
Actually, I would prefer to just start discussing this tomorrow, and then hopefully I can gather something for you guys by the end of tomorrow. So that's
okay. That would be great. Thank you very much. Thanks.
No
that's super helpful.
Yep.
Okay. So I want to leverage like the rest 20-ish minutes to go through this approach and see what's the pros and cons in this approach. I think we already covered some of that in the meeting we had like several weeks ago. I think I just want to like get a kind of dig deeper and try to finalize all the thinkings here, so that like just like, hey, this is one option we have. If we and we need to wait for the feedback from other folks, especially for Windows folks. But let's finish the thoughts on this option and so that this is complete. And then if there's any other option, we can do the same. So so basically the idea is like the main idea using supplementary group is trying to decouple ownership from access control. So basically like right now we couple them together inside Mesos. So basically we change the owner of the volume to be the same user as the container, so that we make sure that the container can access to the volume, but that's not necessary. If we decouple them, so the volume can be still owned by, for example, agent user, which is root, but we can set up the ACLs or access control properly so that the container can access to the volume even if they're not under the same user. So the idea is for sandbox, for example, the sandbox itself can be still owned by root, like the agent user pretty much. And we can change the owner. We can add we can generate a supplementary group, say A, and then we can change the primary group of that sandbox to be A, so that any container has this supplementary group A can access to the sandbox. So that's all the access control kind of problem. Yeah. Any questions so far? And the sandbox mode should be set to like 770 to make sure that the users under the same group can access to the sandbox. Because the owner of the container might be like nobody, and you want to make sure that it can access the sandbox by changing the mode to be 770, so group access can be done.
So is the GID then attached to the sandbox or attached to the user account?
Both. So the primary GID of the sandbox directory should be that supplementary group. And you also, when you launch the container, the process supplementary group list will need to have that supplementary group ID.
So when you create the sandbox, you fish a sandbox GID out of a pool, and then you inject that as the primary GID for your credential when you construct a credential for the task.
Yes.
Not a primary. It will be a supplementary.
Yeah, it's a supplementary group, not primary
group can be any group specified by the container or anyone else.
Don't you want it to be the primary? Don't you want it to be the primary because you want the sandbox to have you want the files in the sandbox to have a consistent GID, group owner?
Well, I mean, that's what set GID does, right? You want, so once you have a set GID based on the directory, all the files you create under that volume will be under that primary GID A. That's what set GID is for. Unless you want the file to be like the file you create in the sandbox, the primary group ID is the same as the user's primary group ID. Unless you want that, then that's a different story. Like we just think about like if you want to support that, then what's the implication? Because especially for sharing, like you have multiple tasks in the same task group wants to share the same volume, and they all under different users and groups, and but you do want them to be able to share the same volume, then and then there's no way you can do that because the file created by one task under group A cannot be accessed by a different task under group B. Does that make sense?
With Linux applications that attempt
Yeah.
to shed their IDs they're launched with, like they try to de-escalate and drop down to nobody.
Sorry, say it again.
So there's Linux applications that when you launch them, they launch with some initial user ID and group ID, but then I'm probably not using the right technical word for it, but they effectively want to drop or at least de-escalate the permissions that they're launched with, and part of that can be changing the user that they run as. So do we see any potential conflict there?
I think it will be okay because it changes only the user. Supplementary groups list will stay the same.
Yeah, I think as Ilya mentioned, like it's okay because even if you change your owner and if you change the user in the group and drop your privilege, since the directory itself, the volume itself has set GID sticky bit set. So all the files created by that thing, created by that process will be has a primary GID of that supplementary group. That's what the GID trick is. Yeah.
Yeah, it really depends on how much privilege you drop. You have to drop privilege, but not drop your groups list.
Yeah, but not. Oh, I mean, James, I see. You're saying like you should not drop the supplementary group list A, otherwise it won't work.
Right. So you have to. I mean, you just have. At this point, we have to be diligent about documenting the semantics and assuming people are going to read that.
Yeah. Okay. Yeah. Anyway, I think this is just like an option. We haven't decided which way to go. We need to wait for the feedback from Windows folks. But yeah, we should document this. Like maybe like attention supplementary group is the last step you do. I don't know like what is it possible or not. Like after you change user, drop privilege, but before. Yeah. Anyway, that's just my issue. We can figure out. Any.
Just to note. So I think I mentioned last time that having 7 on the group is kind of opening the access to a lot of other things. And for example, if all of the service accounts are of the group service accounts, that pretty much means all of the services on the host would have access to other services, sandboxes. But,
yeah, but but Ian, the 770, the second 7 for the group here is only for that supplementary group A, which is all generated by agent. Like ideally, no one should be under that group. So yeah, I think that does have some implication, especially like if you have like a group structure, organization structure, you have a service account. Like you say your user G is under group Eng, and previously any user under group Eng should be able to see my sandbox. But right now with this change, then they won't be able to see the sandbox because the group of sandbox it's a temporary like GID A, and that has nothing to do with eng. So any other user, so except G can access to my sandbox, no one else can access to the sandbox. Like you SSH to the box under G, then you can access the sandbox. But if you SSH to the box using like James, then even if James is in the same organization eng, it cannot access the sandbox, which is kind of slightly different than the previous like semantics.
Okay, yeah, I guess I was slightly confused by the discussion a little earlier. Yeah, if it's the ephemeral sublimation group. Okay.
Yeah, I think maybe that's okay, because I think the like we should discourage people to try to log into the box if possible. I think the main thing we want to prevent is like one container under different framework, under a different organization, be able to access to the sandbox by just writing a script in their job, which is bad. So that's something that we mainly want to prevent from. So that's the second user story we want to support. I think that should not break that. Yeah, and we need to set GID on sandbox directory for that. This is for the sandbox case. We need to add one more for the sandbox volume, because I think that does complicate things into this. Thanks, James.
So I have a question on upgrade. So we're changing the way ACLs are set up on the sandbox, right? So I guess it should not affect any upgrades from an agent that doesn't support this versus an agent that supports whatever decisions are made over here. Because it'll do it only for new container launches, right?
Yeah, so that's another thing that we need to consider. So upgrade story. I think at the very least, like if we can say for old containers like launched by the previous agent, it has the old way of launching the container.
Yeah.
And the new container, I think the only problem I can see is like there's some volume that's shared by an old volume and an old container, new container. That would be problematic. Yeah, we need to think about that. I think for sandbox, it's not an issue, because sandbox
is fine. It's individual containers, so it should be okay. But for
I think it might be a problem for persistent volume, because one might use persistent volume. Like either we need to clear a document that if you want to do that transition, you have to drain the task and relaunch the task.
Yeah, so the upgrade story, at least so for persistent volumes, we need to really think about the upgrade story then.
Yeah, that's a good point. Yes. We need to think about it. Okay, so did everyone get the general idea? Like any comments so far? So Ian, so are you guys? I remember we used to have a discussion on that, and you guys like want to explicitly set a group to like I remember some discussion you guys have that you don't want to change the group to a random group, and you do want to maintain the primary GID of the one that create the volume. Is that still a limitation, or is that still a constraint that you guys still want to make sure that?
I don't think that's the issue I raised last time. But unless James knows something else, I think it's fine.
Okay, so I think the other user story we have is the sandbox of each container should be protected, so that container in a different user cannot access to other users' container. I think that should be okay, as long as if we make sure that the supplementary group assigned to each container is different. I think that does open a question where like things there are like limited number of there are a limited number of GIDs that we can assign. So probably like a flag saying like, hey, this is the range we want to reserve for agent, and the agent will dynamically assign a GID to each container. I think as long as I think we need to consider like terminating the container sandbox as well, because people want to debug after the container is terminated. So we have to make sure that all these containers, including terminated containers, do not share the same ID, do not reuse the same ID. Otherwise, then we can run into an issue. But I think it's okay, because that ID is reserved by agent. No user that access to the box should have that GID. So it might be okay. I'm not sure like any comments on this, any concern on this.
You mean okay, Jim's speech.
Sorry, go ahead, Ian.
No, I think so. Are we now talking about the sandboxes living longer than the container?
Yeah, so the sandbox will live longer than the container, right? Because when the container terminates, we still maintain a sandbox there for a while until it gets GC'd. The primary reason for that is like people want to debug, and they want to debug after the container terminates. They want to get the logs.
Right. So it almost this suggests to me that we have to have a management component for the sandboxes, and GC could be just part of its functionality. But then you can think of things that you might want to plug into it, which would take care of things like, for example, unreserve some of these IDs. When the sandbox gets GC, and then you probably want to GC not by path but by container, that sort of thing. But that doesn't sound like a short-term or easy solution. So
yeah, I think. Yeah, I think at the very least, I do want to make sure that active containers do not share the same ID, same GID. Otherwise, it's going to be problematic because like you can write some script to scan the agents, the sandbox agents work there, and then like you can suddenly access to some other user's sandbox, which is unfortunate. Like we should at the very least prevent that. So that poses a limitation on the number of active containers you can have on the agent, but I think that should be okay because they're like the GID.
No, you can't. So you shouldn't have traverse permissions to get along there. So to traverse between two sandbox containers, you have to go through intermediate directories, right? And then the intermediate directories are not owned by any one of those supplementary groups, and you don't have traverse.
Oh, I see.
So basically, to get from a sandbox, you have to go ... and then path up to the next sandbox, which requires that you have traverse for the intermediate directories.
I see, and then we make sure the intermediate directory is not having this supplementary group.
Right, so if you make sure the intermediate directory is not owned by any one of those supplementary groups and that it has the correct permissions, then we should be okay.
Okay, that's a good point. Yeah, okay. Yeah, I don't know that. Okay. Okay, that sounds fine. I think that use case sounds fine. I think, so another user story is that I want a container to be able to rewrite the host volume with a relative path. So sandbox volume. I think this is not the, so we have two different types. Like, let's talk about the sandbox volume, not like from the parent, but just from itself. So I think this is the user that captured that. So the volume directory is on, yeah, thanks, Ilya. I think you fill the doc by I think, yeah, thanks, Ilya. I didn't notice that you fill the doc with all the rest of the stuff, but that's great. So volume directory is owned by root GID. Okay, that's what we discussed above. Sandbox directory has set GID flag and ensure this has a virtual inherit GIDs. So this one, BSD has different semantics.
So this use case is the sandbox path isolator?
Well, this is, yeah, actually this is in a mess. I mean, this is kind of a mess right now. So I try to do some cleanup on that. So this is the, this is actually handled by the fastest isolator right now. But we should like pull this logic out into a volume, like sandbox volume isolator.
So it's supposed to be a relative path within the sandbox. It's not.
Yeah. So basically, like a relative path. The host path is relative. Yeah, it's kind of a legacy issue. Like initially, we introduced volume. We just say we have a host path and the container path, and the container path can be relative. Host path can be relative too. If it's relative to the sandbox. But later we realized that we have so many other volumes, so this model is not going to work. We have to introduce a source, and then we have to introduce different type of sources. But we haven't like migrated old way to the new way. So I think the first thing we need to do is like deprecate the old way and introduce the new way of using sandbox volume by specifying the source to be sandbox, and you specify a path which has to be relative. And then we also first class host path. The host path basically means the host path is absolute. So we need to like clean this up and deprecate the old way of launching that, and then it will be much clearer. Does that make sense?
Yeah, that makes sense.
Okay. Right. Okay. So yeah, inherent GID. I think we need to. So maybe for BSD, maybe we either say we don't care, or we do a recursive changing the set. We do a recursive set GID basically.
Hello.
Hey.
So I was wondering, when you say inherent, you mean inherent when you create a new file or a new directory, or inherent when you want to access to the existing file in that volume?
On Linux, when you create a new file or directory under the directory that has a setGID flag, that newly created file will have the same setGID and GID.
Yeah, so I actually just did an experiment on my Mac, which is BSD based, right? But although when I used ls-l, it didn't show that the subdirectory I created under the setGID directory shows the ASP on the setGID when I use ls. But I think it actually worked. So I am able to set GID on a directory, create a directory inside that directory using another account but the same group, and I'm still be able to create something else inside that directory.
With the group ID, I think the experiment I did is like I changed the top levels like GID to be a different one, and then
Yep.
Then it's not inherited. So if you have, like, say you have top level A, and then you have a B, like B nested under A, and if you change the A's GID bits and GID to be like a different user than before, and you when you create another file under B, which is nested under A, that file is not going to get.
Yeah. So I think inheritance only happens when you create new thing. It's not, you cannot change. It's not inherited when on existing sub files or subdirectories.
Yeah, I need to do some experiment on Linux, see if that's the same behavior. But I think for sandbox it's okay because we never changed the GID.
Okay. Just a comment.
That's probably okay.
That's I do observe that things are inherited if you create new stuff.
Oh yeah, that's true. I mean, I think the experiment I did was trying to change the GID. I wish like once you change the top level GID supplementary, it changes top level GID, and then that will get inherited for all the rest of this hierarchy. So whenever you create a file under a nested group, like nested directory, and that will under the same group on the top level directory, new one. But that's not the case. Sounds like
I'll probably
at least
test
on BSD. I need to test Linux on that.
I'll probably test something in my Linux box later.
Okay, yeah, that's great. I need to clear this up as well.
So that's the same semantics for ACL inheritance and generally everything as well. So even on Windows, if you change the protected ACL that's getting in for a directory tree, the shell code manually reflows that. There's no like kernel magic that
I see.
That change.
I see. Got it. So there's no so that's okay. So if I want to change the supplementary GID for the group for the directory, then I have to do a recursive set GID. So this is no different than.
Yeah, ACLs is the same. ACLs
okay. Even the rich ACL or like NFS ACL does not support that.
Right.
Oh, okay.
It's not done. Yeah, it's not done. I don't know about the rich ACLs. I don't know Windows. It's not done in the kernel. It's done in the shell by the system, by the library calls.
Okay. Sorry guys, I think we are running out of time, and I think this is great. I will go through this, and also I will wait for the feedback from Microsoft guys. I think I'm excited of a follow-up meeting between a small group. I'm probably now you hijack this, working group meeting for this. But I think we should definitely follow up. And one thing I will do personally is trying to clean up these sandbox volume, host volume things so that we can deprecate the old way of launching using volume. So that's and create documentation for that. I think right now, as James pointed out, like we have so many types and we don't have good documentation on that, and we should have that. And as part of the work I want to do for some of the stuff, I need to do some cleanup on this. I'll do that part, and I'll set up the follow-up meeting once I get the feedback from Microsoft guys. Anyway, thank you guys, and this is a good discussion, and we'll see you in 2 weeks in this working group meeting. Thanks, guys. Sorry about that. I have to go.
Bye.
Bye.
Bye. See you guys.
Bye.
See ya.